Hey everybody, so today we're going to be learning from Chapter 1, Lesson 7, Ratio and Rates Problems. So remember to put this into your table of contents and just add the title up here. Okay. Today we're not learning anything really new. We're kind of just putting together everything we've learned from Lessons 1 through 6, and we're going to practice how to solve ratio and rate problems, and we have these two situations here. So I would maybe take a minute, pause the video, and copy these two down. And I can move the computer forward so that you can see a little better what these say. Okay. So let's start with the first one. So the problem says out of 30 kids, 13 have a cat. Predict how many of 300 kids have a cat. So right away, I notice that we have one ratio already. It says out of 30 kids, 13 have a cat. Okay, so I'm going to write that ratio over here. "13 cats for every 30 kids." Okay. Now I want to solve for how many cats 300 kids have. Okay, so to do that, I'm going to use a strategy called equivalent ratios. Okay, and if you notice, I know that there are 300 kids. What I'm trying to solve are how many cats 300 kids would have. So I did put 300 kids on the bottom over here in the denominator, just because over here I also had kids here. Okay, so I kept them the same. And I'm going to say that these ratios are equivalent. So knowing that, I can do this. I'm going to think to myself, how can I get from 30 to 300? And if you can do that mental math, go ahead and do it. You might need a calculator, okay, to try to see if your guess is right. And remember, we're going from a smaller number to a larger number. So that means if we were in a ratio table, we would be scaling forward, okay? So we're going to be multiplying. We got to multiply 30 by some number to get 300. But let's say we don't know what that number is. So if we didn't know what that number was, we could go in the opposite direction. Okay, if we went in the opposite direction, I can't see that very well. If we go in the opposite direction, we would just need to divide 300 by 30, and we would be able to find that number that we could divide and multiply by. Okay, so just on the side over here, 300 divided by 30 equals 10. Okay, so I did 300 divided by 30 and I got 10. That means if I did 300 divided by 10 to go in this direction, I would get 30. And if I did 30 times 10 in this direction, I would get 300. Okay, multiplication and division undo each other. So you will always have the same number here if you're multiplying and if you're dividing. Okay, so again, if you don't know what to multiply by, you can always use this over here, 300 divided by 30, to find that out. All right, so whatever I do to the bottom, I'm going to do to the top, since I'm using an equivalent ratio strategy. So 13 cats times 10. Okay, and if you can do that mental math, awesome. If you're having a little trouble, just use a calculator, because remember, we can use a calculator in this chapter. And this is what I wanted to find. Okay, so 13 times 10, 130 cats. So for every 300 kids, they have 130 cats. Okay? Alright, and I'm going to write our strategy down. Okay, now let's move on to our next one. An elephant drinks 200 gallons every 4 days. How much does an elephant drink in 28 days? And again, this is nothing new that we're doing. We've been doing this before in class. We're just using certain strategies to try to solve for these problems. So when you try to do them on your own, you have a couple strategies that you can use. Okay, so the first ratio I see is an elephant drinks 200 gallons every 4 days. Okay, so I'm going to put that in ratio form. So I want 200 gallons in my numerator and 4 days in my denominator. Okay. And I'm going to use the equivalent ratio strategy first, and then I'm going to use a second strategy. So since we just did this one, let's try it again over here. So 200 gallons per 4 days, and I want to know how much does an elephant drink in 28 days. Okay, so I'm going to make sure that 28 days is in the denominator, since I have days in the denominator here. Now I'm going to figure out what I need to multiply 4 by to get 28. Because again, I'm going from a smaller number to a larger number, so I know I need to multiply. And maybe I don't know the mental math to figure out how I can get from 4 to 28. Well then, again, I could go in the opposite direction and divide. So if I go in the opposite direction, I'm going to do 28 divided by 4, and I'm going to get 7. So that tells me if I divide 28 by 7, I'll get 4. And if I multiply 4 by 7, I'll get 28. Okay, so now that I figured out how I got from 4 to 28, now I can do the same for the top. Whatever I do to the bottom, I'm going to do to the top. So 200 times 7, you might need to use a calculator for that. So 1,400 gallons. Okay, so an elephant drinks 1,400 gallons in 28 days. Again, that strategy was called equivalent ratios. The next strategy we're going to learn is a little new. Not so new, but we haven't tried it yet here. Okay. So we are going to use a unit rate strategy. This is just a strategy that allows us to get our ratio, our original ratio, into its unit rate, and then we're going to use the unit rate to solve. Okay, so we have 200 gallons for every 4 days. What I'm going to do is get this into its unit rate. So to get it into its unit rate, I'm going to divide the bottom and the top by the denominator. So my denominator is 4. So I'm going to divide the denominator by 4 and the numerator by 4. Okay. Then I'm going to get something over 1. And that's what we always want our unit rate to be, something over 1. So 4 divided by 4 is going to be 1, and 200 gallons divided by 4 is going to be 50 gallons. Okay, so we figured out this elephant drinks 50 gallons in one day. So every day the elephant drinks 50 gallons. Now I'm going to use this unit rate. Okay, I'm going to use my unit rate to figure out how much the elephant drinks in 28 days. I know how much he drinks in one day, so if I know that, I could figure out how much the elephant drinks in 28. This is very similar to the dimensional analysis we did in one of our other chapters. Okay, remember when we had to convert from, convert from like cups to pints? This is similar, okay? So 50 gallons per one day. Since I have days in the denominator, I want to make sure that I have days in my numerator when I'm multiplying. That way, days cancel out, okay? They're going to cancel, and I'm left with gallons, because I just want to know how much the elephant drinks. All right. And then, again, when I'm multiplying fractions times a whole number, I can imagine there being a 1 underneath and just multiply straight across. Okay, so 50 times 28, that's going to be 1,400 gallons, because that's the unit that's left. And 1 times 1 is going to be just 1. So my answer is 1,400 gallons. And if you notice, I got the same answer here as I did up here. Okay, this strategy right here is just going to be called the unit rate strategy. Okay, so you have two strategies to figure out how you can solve different ratio and rate problems.